We send text in. AI says, okay, this music. Okay, here, this one. I am here at Computex. I will make you like me best. Sing it with me. I really like NVIDIA. Okay, so this is the word. These are the words. These are the words. And hey, voice mod, could you write me a song? These are the words. Okay, play it.
I am here at Computex. I will make you like me best. Yeah, sing it with me. I really like NVIDIA.
Okay, so obviously this is a very, very important new capability, and that's the reason why there's so many generative AI startups. We're working with some 1,600 generative AI startups. They're in all kinds of domains, in language domains, in media, in biology. This is one of the most important areas that we care about. Digital biology is going to go through its revolution. This is going to be an incredible thing. Just as we had Synopsys and Cadence help us create tools so that we can build wonderful chips and systems, for the very first time, we're going to have computer-aided drug discovery tools. And they'll be able to manipulate and work with proteins and chemicals and understands disease targets and try all kinds of chemicals that previously had never been thought of before. Okay, so really, really important area. Lots of startups, tools, and platform companies. And let me show you a video of some of the work that they're doing. Play it, please.
Generative AI is the most important computing platform of our generation. Everyone from first movers to Fortune 500 companies are creating new applications to capitalize on generative AI's ability to automate and co-create. For creatives, there's a brand new set of tools that would be simply impossible a few years ago. Adobe is integrating Firefly into their creative apps. Ethically trained and artist-friendly, you can now create images with a simple text prompt. Or expand the image of your real photos to what lies beyond the lens. Productivity apps will never be the same. Microsoft has created a co-pilot for Office apps. Every profession is about to change. Tab9 is democratizing programming by tapping into the knowledge base of 1 million developers to accelerate application development and reduce debugging time. If you're an architect or just thinking of remodeling your home, Planner 5D can instantly turn a 2D floor plan to a 3D model. And right here in Taiwan, Anhorn Medicines is targeting difficult-to-treat diseases and accelerating cures.
Incredible, right? Just utterly incredible. There's no question that we're in a new computing era. There's just absolutely no question about it. Every single computing era, you could do different things that weren't possible before. And artificial intelligence certainly qualifies. This particular computing era is special in several ways. One, it is able to understand information of more than just text and numbers. It can now understand multimodality, which is the reason why this computing revolution can impact every industry. Every industry. Two, because this computer doesn't care how you program it. It will try to understand what you mean because it has this incredible large language model capability. And so the programming barrier is incredibly low. We have closed the digital divide. Everyone is a programmer now. You just have to say something to the computer. Third, this computer, not only is it able to do amazing things for the future, it can do amazing things for every single application of the previous era, which is the reason why all of these APIs are being connected into Windows applications here and there, and browsers, and PowerPoint, and Word. Every application that exists will be better because of AI. You don't have to just AI, this generation, this computing era, does not need new applications. It can succeed with old applications, and it's going to have new applications. The rate of progress, because it's so easy to use, is the reason why it's growing so fast. This is going to touch literally every single industry. And at the core, just as with every single computing era, it needs a new computing approach. And in this particular era, the computing approach is accelerated computing, and it has been completely reinvented from the ground up. The last several years, I've been talking to you about the new type of processor we've been creating. And this is the reason we've been creating it. Ladies and gentlemen, Grace Hopper is now in full production. This is Grace Hopper. Nearly 200 billion transistors in this computer. Oh, 等一下，谢谢。哇，蛮重的。Look at this. This is Grace Hopper. This processor is really quite amazing. There are several characteristics about it. This is the world's first accelerated computing processor that also has a giant memory. It has almost 600 gigabytes of memory that's coherent between the CPU and the GPU. And so the GPU can reference the memory, the CPU can reference the memory, and any unnecessary copying back and forth could be avoided. The amazing amount of high-speed memory lets the GPU work on very, very large data sets. This is a computer. This is not a chip. Practically the entire computer is on here. Uses low-power DDR memory, just like your cell phone, except this has been optimized and designed for high-resilience data center applications. Incredible levels of performance. This took us several years to build, and I'm so excited about it. And I'll show you some of the things that we're going to do with it. Janine, thank you. 谢谢. You're supposed to say, Nadi. Mike. 不要客气. Okay, so 4 petaflops transformer engine, 72 CPU cores. They're connected together by a high-speed chip-to-chip link, 900 gigabytes per second. And so the local memory, 96 gigabytes of HBM3 memory, is augmented by LPDDR memory across this link, across a very, very large and high-speed cache. So this computer is like none other the world's ever seen. Now, let me show you some of its performance. So I'm comparing here on 3 different applications. And this is a very important application. If you've never heard of it, be sure to look into it. It's called Vector Database. Vector Database is a database that has tokenized, that has vectorized the data that you're trying to store. And so it understands the relationships of all of the data inside its storage. This is incredibly important for knowledge augmentation of the large language models to avoid hallucination. The second is deep learning recommender systems. This is how we get news and music and all the text that you see on your devices. Recommend, of course, music and goods and all kinds of things. Recommender system is the engine of the digital economy. This is probably the single most valuable piece of software that any of the companies in the world runs. This is the world's first AI factory. There will be other AI factories in the future, but this is really the first one. And the last one is large language model inference. 65 gigabytes. 65 gigabytes is a 65 billion parameters is a fairly large language model. And you can see that on a CPU it's just not possible. The CPU is simply not possible. With Grace Hopper, with Hopper on an x86, it's faster, but notice it's memory limited. You could, of course, take this 400 gigabytes and cut it up into a whole bunch of small pieces, shard it, and distribute it across more GPUs, But in the case of Grace Hopper, Janine, 再给我一次. Oh, Janine doesn't speak Chinese. 不要紧，拍谁? Okay. Grace Hopper has more memory on this one module than all of these. Does that make sense? And so as a result, you don't have to break the data into so many pieces. Of course, the amount of computation of this is higher, but this is so much easier to use. And if you want to scale out large language models, if you want to scale out vector databases, if you want to scale out deep learning recommender systems, this is the way to do it. This is so easy to use. Plug this into your data center, and you can scale out AI. Okay? So this is the reason why we built Grace Hopper. The other application that I'm super excited about is the foundation of our own company. NVIDIA is a big customer of Cadence. We use all of their tools. And all of their tools run on CPUs. And the reason why they run on CPUs is because NVIDIA's data sets are very large. And the algorithms are refined over very long periods of time. And so most of the algorithms are very CPU-centric. We've been accelerating some of these algorithms with Cadence for some time, but now with Grace Hopper, and we've only been working on it for a couple of days and weeks, the performance speed up, I can't wait to show it to you, is insane. This is going to revolutionize an entire industry, one of the highest compute-intensive industries in the world, of course, designing chips, designing electronic systems, CAE, CAD, EDA, and of course, digital biology. All of these markets, all of these industries require very large amounts of computation, but the data set is also very large, ideal for Grace Hopper. Well, 600 gigabytes is a lot. 600 gigabytes is a lot. This is basically a supercomputer I'm holding in my hands. This 600 gigabytes is a lot. But when you think about it, when we went from AlexNet of 62 million parameters 12 years ago and trained on 1.2 million images, it is now 5,000 times bigger with Google's Palm. 5,000 times bigger with 340 billion parameters. And of course, we're going to make even bigger ones than that. And that's been trained on 3 million times more data. So literally in the course of 10 years, the computing problem of deep learning increased by 5,000 times for the software and 3 million times for the data set. No other area of computing has ever increased this fast. And so we've been chasing the deep learning advance for quite some time. This is going to make a big, big contribution. However, 600 gigabytes is still not enough. We need a lot more. So let me show you what we're going to do. So the first thing is, of course, we have the Grace Hopper superchip. Put that into a computer. The second thing that we're going to do is we're going to connect 8 of these together using NVLink. This is an NVLink switch. So 8 of this connect into 3 switch trays into 8 Grace Hopper pod. These 8 Grace Hopper pods, each one of the Grace Hoppers are connected to the other Grace Hopper at 900 gigabytes per second. 600 gigabytes, 900 megabytes per second, 8 of them connected together as a pod, and then we connect 32 of them together with another layer of switches. And in order to build this, 256 Grace Hopper superchips connected into 1 exaflops. 1 exaflops. You know that countries and nations have been working on exaflops computing and just recently achieved it. 256 Grace Hoppers for deep learning is 1 exaflop transformer engine, and it gives us 144 terabytes of memory that every GPU can see. This is not 144 terabytes distributed. This is 144 terabytes connected. Why don't we take a look at what it really looks like? Play, please. This is 150 miles of cables, fiber optic cables, 2,000 fans, 70,000 cubic feet per minute. It probably recycles the air in this entire room in a couple of minutes. 40,000 pounds. 4 elephants. 1 GPU. If I can get up on here, this is actual size. I wonder if this can play Crisis. Only gamers know that joke. So this is our brand new Grace Hopper AI supercomputer. It is 1 giant GPU, utterly incredible. We're building it now. Every component is in production, and we're so excited that Google Cloud, Meta, and Microsoft will be the first companies in the world to have access, and they will be doing exploratory research on the pioneering front, the boundaries of artificial intelligence with us. We will, of course, build these systems as products. And so if you would like to have an AI supercomputer, we would, of course, come and install it in your company. We also share the blueprints of this supercomputer with all of our cloud suppliers, so that our cloud partners, so that they can integrate it into their networks and into their infrastructure. And we will also build it inside our company for us to do research ourselves and do development. So this is the DGX GH200. It is 1 giant GPU. Okay? In 1964, the year after I was born, was a very good year for technology. IBM, of course, launched the System 360, and AT&T demonstrated to the world the first picture phone. Encoded, compressed, streamed over copper telephone wires, and twisted pair, and on the other end, decoded. Picture phone, little tiny screen, black and white. To this day, this very experience is largely the same. Of course, at much, much higher volumes. For all of the reasons we all know well, video calls is now one of the most important things we do. Everybody does it. About 65% of the internet's traffic is now video. And yet, the way it's done is fundamentally still the same. Compress it on the device, stream it, and decompress it on the other end. Nothing changed in 60 years. We treat communications like it goes down a dumb pipe. The question is, what would happen if we applied generative AI to that? We have now created a computer. I showed you, Grace Hopper. It can be deployed broadly all over the world, easily. And as a result, every data center, every server will have generative AI capability. What would happen if instead of decompression, streaming, and recovering, decompression, what if the cloud performed generative AI capability to it? Let's take a look.
The future of wireless and video communications will be 3D, generated by AI. Let's take a look at how NVIDIA Maxine 3D, running on the NVIDIA Grace Hopper Superchip, can enable 3D video conferencing on any device without specialized software or hardware. Starting with a standard 2D camera sensor that's in most cell phones, laptops, and webcams, and tapping into the processing power of Grace Hopper, Maxine 3D converts these 2D videos to 3D using cloud services. This brings a new dimension to video conferencing with Maxine 3D visualization, creating an enhanced sense of depth and presence. You can dynamically adjust the camera to see every angle in motion. Engage with others more directly with enhanced eye contact. And personalize your experience with animated avatars, stylizing them with simple text prompts. With Maxine's language capabilities, your avatar can speak in other languages, even ones you don't know.
NVIDIA 正在使用生成式 AI 来发明新的交流方式。NVIDIA は生成系 AI を用いてコミュニケーション技術に革命をもたらします。
NVIDIA Maxine 3D, together with Grace Hopper, bring immersive 3D video conferencing to anyone with a mobile device, revolutionizing the way we connect, communicate, and collaborate.